In this video, we are going to talk about the first part of section 9.1, which is radical expressions and functions. So the first part we want to look at is finding square roots, and it's going to be very important that you take some time to memorize perfect square numbers. So for example, 1 squared is 1, 2 squared is 4, 3 squared is 9. All of these numbers, 1, 4, 9, 16, so on and so forth, these are called perfect square numbers. And in order to work with radical expressions, both now and into the future, it's going to be important that you can recognize perfect square numbers. Okay, so spend a little time in ingraining those into your brain. In math, we say that if b squared equals a, then b is equal to the square root of a. And they say principal square root because principal indicates the positive square root. If we want the negative square root of a, we would put a negative out in front, which would actually mean -1 times the square root of a. Okay? So if you don't see a negative, of course, then what we're looking for is the principal square root. So first you'd be asked to evaluate. So what's the square root of 25? Well, the principal square root of 25. What number, when you square it, gives you 25? That's 5. Here we would want the negative square root of 16. Well, thinking of this as -1 times the square root of 16, well, of course, that's -1 times 4, which is just -4. And you could write just -4. You don't have to write all those steps, but I wanted you to see what that looks like. Here, square root of 64 plus the square root of 21, I do not put those together and get the square root of 185. Instead, I treat them separately. Square root of 64 is 8. And the square root of 121 is 11, so 8 plus 11 would be 19 on that one. Similarly, when you can find the square roots of other components, like this is the square root of 0.09, which is 9/100ths. So you could think of this as the square root of 9/100ths. And if you could type that into your calculator, or you can think of these as square root of a fraction as the square root of the numerator divided by the square root of the denominator. And so the square root of 9 is 3, and the square root of 100 is 10. So 3/10 is my answer. But since it started as a decimal, I want you to write the final answer as a decimal as well. Okay, so the square root of 9/100ths is really 3/10. Similarly here, the square root of 25/9, well, square root of 25 is 5, square root of 9 is 3. It started as a fraction, so go ahead and leave that as a fraction. The square root of -100 causes us a problem. If you type this into your calculator, chances are you would get an error, because we can't actually take the square root of a negative number. Well, at least not yet, we can't. So this is not a real number, and so we are just going to write that, and because for right now we can't deal with that, okay? But here I can take the square root of 36, which is 6, and I can take the square root of 100, which is 10, and 6 minus 10 is -4. So there I can work that out and get an answer. Okay, so when you are considering the square root of 49, you're asking yourself, what number, when I square it, gives me 49? So what number, when squared, gives 49? That's what we're actually asking ourselves, okay? Well, interestingly enough, there are two answers. 7, because 7 squared is 49, but also -7, when I square it, gives me 49. But we are looking for, so we don't know necessarily which actually is the one we're wanting, but since this is the positive or principal square root, we would be looking for the positive answer, or the principal answer, which is 7. But when you have a variable like x, in order to ensure that it is positive, we're going to use absolute value symbols in there, okay? So be aware of that. Whenever we're starting to work with variables now, unless it says assume that the variables are non-negative, we're going to need to imply or include those absolute value symbols. Okay, so let's take a look at what that looks like. Well, the square root of 3 squared, that's the same as the square root of 9, and again we're looking for the principal square root, so that's just 3. We don't need to put an absolute value because 3 is already positive. However, the square root of 81x squared, well, the square root of 81 is 9, and the square root of x squared is x. But since we don't know whether x is positive or negative, we actually need to include the absolute value here. So we can, I wouldn't be opposed if you put the absolute value around the 9, but since it's already positive, it doesn't need it. We can just leave it as this 9 times the absolute value of x. Similarly here, if I factor this, this becomes x minus 5 squared, and I'm taking the square root of that, right? So then that, when I take the square root of something squared, it's just what I have, which is x minus 5. But since we want that to remain positive, we have to put that in absolute values. Okay? And similarly here, I'm taking the square root of 16x to the 12th. Oh my goodness, that is a lot. X to the 12th, remember, is x squared times x squared times x squared times. You get the idea. How many times are we going to do it? That's right. There are 1, 2, 3, 4, 5, 6 of those. Square root of 16 is 4. And then each one of these would come out as an x, so I'd have an x to the 6th. Now, this is going to be positive as it is, but when it doesn't say assume all variables are positive, we're going to go ahead and put the, I guess I shouldn't write it slantways, I should write it up and down. Yeah, we're going to go ahead and put the absolute values there. Okay. Even though x to the 6th is positive, and we're going to talk about that again in a little bit, okay? So for now, practice those perfect square numbers and how we're taking the square root of them, because it's going to be really important as we continue to go on. Okay, keep up the good work. I'll see you in the next video.